I'm going to introduce our two speakers today. So first up, we're going to have Matt Tokarik. Matt is the president of Subterra. He is a professional engineer. He also has quite a few papers on geothermal cited to his name. He's also a lecturer and an instructor at a few universities in Canada. We're very pleased and very honored to have him at the helm of our company. He's a consummate engineer, very technical person who is able to explain this in a way that everybody can understand. And he will be our first speaker coming here to talk about what geothermal is, what it does, and the technical aspect of how it performs. Next, we're going to have Michael Schierl with Julius Capital. He is the founder of Julius Capital. He is also a partner at Croak, Fairchild, Duarte, and Barris. Julius Capital is a partner of Subterra in our U.S. expansion. Of course, Michael is an alumni of Notre Dame and also a graduate of Harvard Law School. And he will be talking to us an awful lot about the financeability, the financial case in general of geothermal, and how it could be used in a creative way to unlock monetary potential of existing properties. And without further ado, I'll hand it over to Matt. Thank you, Matt.
Thanks, Kareem. Thank you for that wonderful introduction, Kareem, and thank you everybody for having us here today. We're really excited to chat with you guys. Like Kareem said, I'll be starting this presentation off, and I'll be talking a little bit about the technical aspects of geothermal, not diving too much into the nuts and bolts, but just to give you an overview of how it works and what to expect on site, as well as how our contracts work in terms of our deboom model, which we'll describe here coming up. So to get started, I just want to set the context for why are we talking about geothermal? What are we actually doing here? Well, as all of you know, we've got an issue facing all of us, which is rising energy costs and a rising energy demand in our buildings, in our campuses, and our portfolios. And tied to that is a rising carbon emission problem that we've all been facing that's causing global warming, temperature issues, extreme weather events. What you may not know is that 60% of carbon emissions in major cities and urban centers come from buildings. Most folks think that it has to do with transportation, but buildings are in fact the largest emitter in our cities, again up to 60%. When you peel back that chart a little bit further, what you'll understand is that 3/4 of that carbon comes from heating and cooling of our buildings. So we've got this massive problem that ultimately has to do with the heating and coolings of our buildings when it comes to solving our carbon challenges. To reiterate that point here, you can see a graph of our rising carbon dioxide concentration in our atmosphere. This has been since 1750, and for anybody who is familiar with history, you'll know that that's roughly the point of the Industrial Revolution when humans really started to start combusting fossil fuels. And you've seen a steady increase, and what that's led to is a rise in our temperature, our average temperature on the Earth by about 1.5 degrees Celsius, which is causing a problem. And primarily, what we're seeing is not just a little bit warmer, a nicer summer day, a little bit warmer winters, but more extreme and more frequent weather events. So more hurricanes, more wildfires, more flooding, more droughts, which is causing broad social and economic concerns. And so we are all here today, of course, to address that carbon issue globally, but also as church members and Catholic members, we've got a duty to help address that as global citizens. So again, when we think about how do we solve for this carbon problem, we're talking about geothermal. And what I like to say is that geothermal is to the building industry what electric vehicles are to the transportation industry, right? This is a massive, massive way to save a really significant amount of carbon, and I'll explain how that works in a second here. But let's just talk about how does this work, okay? So you're probably looking at this thing saying, I know we're gonna drill some stuff into the ground, but what's actually going on? I like to start with a little analogy, which is your refrigerator at home. So I'll give everybody 5 seconds here to think, how does my refrigerator at home work? You probably never thought about this, right? I put my beer in the fridge and I pull it out and it's cold. The trick to that is that there's no such thing as making cold, right? It feels like your refrigerator is making cold, but there's no such thing. All we can do is remove heat or move heat from one spot to the other. So in fact, when you think about the inside of your fridge being cold, there has to be heat rejection somewhere else. And so if you put your hand on the back of your fridge, you can do this when you go home tonight or tomorrow, you'll actually notice that it's warm. And so what's happening there is what we call the refrigeration cycle, hence refrigerator. And we've got a compressor that's driving refrigerant fluid between coils in your fridge and out of your fridge, which is moving the heat from inside to the outside, thereby giving the appearance of making cold. Okay, so that's how your refrigerator works. A geothermal system works on the very same principle, except instead of having the inside of your fridge, you can think about the inside of your building, and instead of having the coils on the back of your fridge, you can think about coils buried in the ground. Okay, and we've got that refrigeration cycle in between those, moving heat from the ground to the building and back and forth. We can reverse that cycle, and we can move heat out of the building, i.e. cool the building, which increases the temperature of the ground. And in the winter season, we can pull that heat back out of the ground and put it into the building to heat the building. So what that ends up making is a thermal battery with the volume of soil under your building with a 1-year charge and discharge cycle. So we're constantly increasing ground temperature, lowering the ground temperature, increasing and lowering. And that's the principle that drives this geothermal system. What it actually looks like in your building is a number of boreholes. You can picture a 6-inch diameter borehole that's going to go down about 1,000 feet. And for a typical point tower, something like this, you might expect something between 50 and 100 boreholes. For a campus like this, or we're doing other projects, Oberlin, for example, you might have 1,000, 2,000 boreholes. Okay, so all of these boreholes are going to be drilled into the ground, connected with piping, and we're going to circulate fluid through them. So that creates your coil. The big reason that these systems are so cool is that they are 3 to 4 times more energy efficient than your conventional system. Okay, so when you think about what's heating your buildings now, your boiler, chiller, cooling tower, compared to a geosystem is 3 to 4 times more efficient. So you get a massive reduction in energy usage. And because we've removed our fossil fuel combustion from on site, we've taken our boiler away, we have a massive reduction again in carbon emissions. So when we talked about that 60% carbon emission coming from buildings, again, most of that which is attributed to fossil fuel combustion-based heating, this is why that solution is so effective at addressing that problem. So as we look into the building, we'll just compare the two cases here. On our left-hand side, we've got what is considered traditional or conventional geothermal. Again, this is probably what most of you would see in your buildings that have a boiler, a chiller, and a cooling tower. That's the typical package that creates hot and cold water that's distributed around the building. On the right-hand side, we remove all that stuff, so we actually gain penthouse space, the most valuable real estate space, obviously, in a building, which can then be used for outdoor amenity, or even in some cases, additional leasable or saleable area. So a really massive win there. It's important to understand that these types of systems can be applied to both new buildings or retrofits. Again, we're standing on a campus that's undergoing and undergone a retrofit to geothermal, so massive application, and can be used in any type of HVAC system that's water-based. So anything, again, this is very typical that you would have in your buildings, fan coil units, heat pumps, VRF systems, radiant systems, anything that you've got or that you would like in your design can be plugged into the geothermal system. The other really cool thing I'll point out before I jump onto the next slide is this phrase, simultaneous heating and cooling. What does that mean? It means that geothermal has the ability to take heat from one spot and move it into another space. So why is this important? Well, think about a data center, for example. A data center is a type of space that is always rejecting heat. It always needs cooling, right? So there's a constant heat being produced, and generally what we do is we actually pay to evaporate that heat into the atmosphere. With geothermal, what you can do is you can take that heat out of the data center that's always rejecting, and you can actually use it to heat an adjoining space. So if you've got a residential space, for example, a dorm, an apartment, etc., that is usually wanting heat, particularly in the winter months, you can take that heat for free and transfer it over, which is why it's such a great application for campuses that have a bunch of different load diversity. Okay, so now you've decided to go geo. How do we actually get this done? There's two paths here that we'll talk about. The first is the contractor path. So this would be your typical design bid build method where There is, but let's talk about, let's hold questions for the end. We'll get to you first at the end of our talk here. If you want to go do it yourself, you would have to go hire the contractor, the designers, as you would with most of the rest of your construction process. But the important things to think about here is you're going to be the owner of this system, so you're going to take all of the risk, you're going to pay the capital costs, and you're going to be the one who is responsible for monitoring and maintaining the field, and really you become the person who's responsible. The other alternative here that we'll talk about is working with Subterra Renewables, and this is an alternate case that's going to remove a lot of these barriers for you. So where you would take the risk as the owner, we're going to provide a performance guarantee that is to the degree guaranteed. If the system goes down, we're going to have to come in and fix the system. Very importantly, we'll talk about this a few more times throughout the presentation, but we pay all the CapEx. Okay, so you guys are going to save all of the line items for your HVAC on your pro forma. We're going to contribute that CapEx. And in return, we'll have a fixed renewable energy fee. So instead of paying the upfront capital cost, you'll basically pay an operating cost through the life. It'll be a fixed fee guaranteed over the life. And then very importantly, we monitor and operate the field for those 30 years. So again, if you're new to geothermal, you want the system, but you're not sure you feel confident operating it, we would take that responsibility on as a partner. What we call this is a D-boom model, design, build, own, operate, maintain. And I'll talk about what's involved in that. And again, as a reminder, for that D-boom offering, you pay one renewable energy fee. That's what we call our monthly cost. So in the D-boom model, again, design, build, own, operate, maintain, you get all of these pieces included in the service offering. So we will do the design. That includes a test borehole to understand the thermal properties of the ground and the drilling conditions. We'll do all the desktop review to design the system, as well as prepare all the financials to understand what the renewable energy fee is going to be. We're going to be the builder. Okay, so we've got not only are we a utility company, but we've got a drilling business as well. We've got over 50 drill rigs, which makes us the largest geothermal driller in North America. And also allows us to control the construction process, right? We don't want you to go out to a different driller who's going to impact your critical path potentially and put your construction at risk. We are going to own that system, so we've put up the capital cost, but we own the system for the 30-year duration. At the end of the 30-year duration, once the contract is expired, you will become the owner of the system. So you will get the system in operating order, and for the remainder of the life of the system, which these systems can last for 100 years, you will have become the owner of that system. And then finally, we operate and maintain, again, very importantly, offering a performance guarantee. If anybody's heard about geothermal in the past, you may have heard some horror stories, frankly, about things going wrong. And in 9 times out of 10, the reason those have gone wrong is because nobody's been watching it. Right? There's usually a good designer behind it with good intentions, but as soon as they hand over the keys, we've often seen many times these systems go out of balance and stop performing because nobody's maintaining them. So to summarize here, we will offer the D-boom structure at no upfront capital cost to the owner. So for that D-boom offering, we charge a renewable energy fee. This is something that's known at the onset. This is something that we calculate after the design, and we will agree on what this is for a 30-year contract. It's going to be fixed. It's not going to move. And again, what you get is all of those pieces of the D-boom, the early optimization and design, the monitoring over that 30-year contract, all of the planned maintenance. So not only are we watching the temperatures and the flows and all of the brains of the operation, but we're sending boots on the ground into the system to change filters and maintain pumps and all those sort of things. And of course, the capital investment. So that's the renewable energy fee. That's sort of how we trade the cost. And all of that is documented and captured in what we call the Geothermal Energy Service Agreement. We call it a GESA for short. The GESA, again, is something that we'll meet on the middle on and have agreement with to set up the geothermal system, to install it, to operate it for 30 years. For that 30-year period, the end user, building owner, will pay the renewable energy fee, And then, of course, at the end of that 30 years, the system will become yours, whoever the owner is on the other end of that. So that's a brief overview of how this all works from a technical standpoint, a little bit from a contractual standpoint. I'm going to pass it over to Michael to now answer the more fun question of, well, how do we actually pay for it?
So it sounds pretty good so far. So the question in everyone's mind is, how the heck can I pay for this? I mean, it's got to be. It was the bubble above my head the first time I heard about this. And so let's go through it. And I'm going to sum up what Matt's already said, and also from my skeptical eyes, how I get involved with this, about bringing this to the US and explaining it with a straight face that this isn't too good to be true. So what's the Subterra value proposition? This is just summing up what you've seen. First of all, we have to start with that guarantee. Probably the most important part. If you're going to do geothermal, you want to make sure it works. So you have the largest company in North America that's got a track record of 8 or 9 years here, and as you'll see, very well backed. So the guarantee, knowing what you're doing, and them coming and guaranteeing that whole system is probably the most important piece to keep in mind to begin with before we get to the financial goodies. Zero capital outlay is great, and that's just true. Anything that's connected to this geothermal system will be 100% paid for by Subterra. They now own it, and when you own something, you got to make sure it works, hence the guarantee. So they're on the job, they have paid for that system. You're going to pay one fixed energy fee for all of the service, that the deboom service that Matt just highlighted. Now, actually, in most cases, it'll be up to you to decide, but that's actually, energy fee is going to be at or below what you're paying already for conventional HVAC. You're already paying the same price as your energy fee in most of our cases. A lot of people who are financial, we're getting more into the financial here, you're going to wonder, what about this whole thing? Does it mess up my debt? Is it permitted? Are they taking mortgages? I could just say, this is entirely off balance sheet. You can do this with any kind of debt structure, and I've done thousands of them. This works. They're not going to mess up your financing. In fact, it'll be viewed as free equity in from someone else to give them a value. I mean, lenders or investors, other people would love if you're doing this, and it's not going to mess anything up. Finally, a little bit of a cherry on top. Because of the Inflation Reduction Act, there's actually very substantial tax credits available for this on the federal level, and we're going to dig into that because I know that's another bubble above everyone's head. You know, what about these ITCs? So the bottom line is they're going to pass the value of the ITC. Subterra will give the value of the ITC right back to the client, right to the university. Okay, so let's first talk about what those incentives are and show how you're going to end up getting them. Starting just with the investment tax credit. The Inflation Reduction Act of 2022, highly complex piece of legislation. Brief summary here, but this is the straightforward way to understand that from your perspective if you're considering a geothermal system with Subterra or without Subterra. The ITCs are available. How they work, the baseline credit is 30% of the capital outlay. So I'm going to use that number throughout. If you had a $20 million project, you're going to have $4.5 million or whatever, $6 million of tax credit. There's add-on credits in the Act. One simple one that you get automatically, if you happen to be in a clean energy community, it's another 10%. They have other stackable credits there, but that one, and that's a substantial portion of the US wherever they have a heritage of having used coal-fired kind of heating or combustion in the past, or coal mining. Those zones are called clean energy communities. For example, Chicago's one. Dallas, or most of Texas. A big part of Colorado. So a lot of those have another 10%. So we're talking 40% tax credits pretty much off the bat. In the States, though, on top of that, there's other stackable additional credits, and I'll give you the example in Colorado. With the state level ITC credits, you can double that, and it could be 60 or 70% ITC credit all in, and there's other discounts on heat pumps and things like that. So a substantial part of this could be your investment tax credit that is able to come back to the client. Now, the thing to remember now we said that is, under the ITC, the owner is the one who gets the ITC. So with conventional, I'd say contractor geothermal, the school or the parish would be the owner because you're contracting someone to build it, you own it. So that's where you would have to apply and get the ITC as the owner if you do it with contracted geothermal. But we're going to explain, that's a hassle, and I'll just give you a 1 minute on tax credits. They can be a nightmare. They sound great. Applying for them, getting it right, getting the credit. Maybe you have to file a tax return to get it. Some of you don't. You may need to resell the credits. Hassle, attorneys, love them, but if you don't need them, it would be much better to just get the number. So that's what Subterra is going to do for you. We're the perfect partner. In our system, Subterra is the owner. So Subterra needs to be the one to deal with all the ITC credit hassle. Applying, getting it right, prevailing wage, apprenticeship requirements, all of that. Subterra will do that. They completely remove the ITC application hassle from you. And you will then get an amount equal to the net tax credit that Subterra gets. They're just passing it on, but they'll do all the work. It's like DBOOM Plus. They'll also do the work on the ITC for you. Now, we're going to get to numbers on this, but remember, Subterra's owning it. They're paying for it. The more that goes on Subterra's budget as part of the geothermal system, the bigger your ITC that you're going to get. So you'll see from when we're talking about this, you can throw in projects you're already planning on doing. I already have a broken down boiler with a building that I got to replace and all that. You can include that in this retrofit or in your new buildings. And now you're going to kill 2, 3, 4 birds with one stone. You might actually get a new system out of something you were going to pay for anyway. And you're going to get an ITC credit back when you add it into the mix. The bigger the CapEx that's in the geothermal system, the bigger the ITC. Okay, here's the point where you say, and I did, one, how is this going to work and what are they going to charge me? I mean, for all of that, you think like, whoa, that's going to be a lot of money. I mean, it just seems like a lot of value, a lot of money. So how do they how do they set this renewable energy fee? And you also wonder about a lot of things, as I do, suspicious, hidden, behind the scenes. What's going on here? How are they screwing me? I'm sorry, I'm at a Catholic conference. How are they taking advantage of me? Because they know this and I don't. We'll just tell you how we will price the energy fee. We go out, we get the facts, we come back, we make a proposal, and we will tell you that. I jumped ahead. I first said this one is, how would it work if you had to invest, say, the $20 million? That is, you have a contracted geothermal provider. Remember, you're the owner of the system. Geothermal might cost $20 million. So here's how it would typically work in an imaginary scenario that could never happen, but I want to explain. If you were to go try to borrow the $20 million from a bank and say, I'd like a 30-year loan, and I'd want to put it in this geothermal, and I'm willing to pay 7%. First of all, the bank would just say, we'll go 10 years maximum. We would never lend against that. Plus, many of these are startup schools and other places. There would be no way you could get that loan or this money yourself. So the only one that can do contractor geothermal is billionaire universities like this one. Hey, I had 20 million laying around, no problem. I'll do it. I got a staff, I'll do it. I got access to capital, so I'll just put it in myself. Or I'll borrow it and with my AAA credit rating. It could never happen for everyone that I'm working with, trying to have startup schools, parishes, retrofits of church buildings. That could never happen. So that's why typically Geothermal can't be made into where it's really needed in a lot of these schools and churches. Now here's what Subterra does. It's very, very simple. Rather than you going to the bank and asking for the 20 million, how about Subterra goes to their $1 billion infrastructure fund and lenders who want to put $1 billion to work, and they ask for the money. And this fund is trying to put that money to work, and Subterra knows what it's doing. So Subterra basically has access to the 20 million, actually $1 billion of money allocated that they can spend on this. And what their lenders are and investors are looking for is something, and this changes over time, but in the rate of 7% or so of a type of a long-term return. You heard yesterday about the horizon, the investment horizon. This is huge. They're going out 30 years. So they get the money. And then in turn, what they do is charge the customer an energy fee that's priced to be a 9% type of return to Subterra. So you see there's a little spread there, and they're basically getting the capital. And that's open book how they're going to charge your fee. And we'll iterate that with you. So very simple. So they're looking for a 9% unlevered IRR. And that's energy fee will be what gives them that. They'll use the energy fee to basically pay their investors, and everyone's happy. So that's how it works. There's no kind of, hey, how much can they afford or whatever. It's just open book. The facts are the facts. Okay, the good thing is that energy fee, because of the inherent efficiency of geothermal, it's at or below what you're paying already. That's just it. It's at or below what you're paying already. The only difference is how you're paying it and the hassle factor. On the left, if you're going to actually try to kind of do a new conventional HVAC system, look at what you have to think of. You've got an electricity bill. You've got a gas bill. You've got that boiler. It breaks down. You've got makeup water. You've got maintenance. You've got capital reserves, all of this, and it's all on you. Now, with Subterra geothermal, you only have 2 bills. Note, we are eliminating that natural gas bill, hence Laudato Si, clean. We're getting rid of the boiler. So you're going to still pay an electric bill, and you're going to pay a single renewable energy fee. And the total of those two are going to be at or below what you're already paying. Just very simple. It's going to be at or below what you're already paying. Okay, let's look at some examples, because how can you make this real without actually thinking about something where you live every day, and I do, on helping to finance church properties. Let's look at a scenario. So let's say you have an 80,000 square foot building. At $500 per square foot, you're thinking it's a $40 million type building. And you're thinking about how to build it and what way to go about with this. So what is your cost? And I'm big on what's your all-in cost. Not just your one-time, capital expenditure. What's your all-in cost to do that? So we'll take it in those 2 parts. So we have to think about this, and I'm going to run through the 3 scenarios. One is conventional HVAC. Second is contracted geothermal. And the third is Subterra geothermal, where Subterra owns the system. Let's look at the numbers. You have a $40 million building. Let's say it's $35 million of general construction and $5 million of HVAC embedded in the project. This is a $40 million building. Of course, you pay that whole thing. You have to come up with that capital. What's your operating cost for that type of a system? New conventional HVAC system, we're going to say it's $1 million a year with these components. You got your annual operating and maintenance. You've got some capital reserves. You pay your gas utility bill and your electric utility bill. And we haven't gotten to Subterra. You have no renewable energy fee. So you got $1 million a year. And over 30 years at 2% inflation, that's going to be $46 million that you put into operating that system. So your all-in cost is $86 million. That's a number. That's something we're going to compare as a baseline. Okay, now let's say you like geothermal, the idea of it, but you're considering doing it through a contractor. Meaning basically, you own the geothermal. That's this column. If you own the geothermal, here's how it works. Well, your 35 million of general construction is the same. The nice thing about geothermal, though, if you connect, and now we have something in the geothermal line, that's essentially the boreholes and some other kind of underlying infrastructure. You still have HVAC, though. So you've got to plug into something under the investment tax credit. That's considered one system. So anything the geothermal plugs into, as long as it's a loop and it's a way you distribute the heat or cool, is part of the system, therefore entitled to the ITC. So now, in this case, contractor geothermal, you've got 15 million that qualifies for the ITC. So there's going to be a $4.5 million ITC, assuming you can live through the hassle of applying for it and getting it and selling the tax credits. You would net another 4.5 million. Now your cost is 45.5. On that front, a little higher. Now on your operating cost, here's the thing, is it's a more efficient system. So you're going to go here, and now you're going to notice rather than $1 million a year on this system, you're going to pay $750 a year. Sounds like a small number, but look at over 30 years, it's 34.5 million. And so here, this is why they say geothermal makes sense. This is more efficient, it's clean, all-in cost is less than conventional. But this is if you hire a contractor to do it. Assuming you can get all through that and you have the ability to do it, you're still paying less, but the big part is you still have to come up with $45 million to put it in. Now let's look at if you work with Subterra. Remember, this is your cost. So the general construction is still yours, but notice the HVAC and geothermal lines, 15 million, is paid by Subterra because they own that component of it. So the ITC credit for that, which goes to the owner Subterra, is still 4.5 million. However, in the Subterra's model, they give that back to the client. So your true net upfront to put in a new building is now 30 million rather than 40. So right off the bat on a new building, you're going to save 10 million on this. This could be a dorm. This could be a multifamily affordable housing kind of project. You're going to have a 10 million reduction in what you have to put up front. Now let's look at the operating cost. Remember, all-in operating cost is still going to be the same or below what you're paying. So you're still paying $1 million a year here. So your operating cost is 46 million. Your all-in cost is lower than each case here, in the hassle factor in very much reduced. All right, click that too early. So you're at 76 million versus 86 million all in, but the key point there is still on your upfront capital cost, much lower. Now let's look at a retrofit. Now let's imagine you have an 80,000 square foot building. It was built a while ago. It's inefficient. The boiler's breaking down. It just can't, it needs a HVAC retrofit upgrade. You can't afford to keep fixing the boiler. Same analysis. So in this case, your general construction is zero. All you're doing is an HVAC retrofit. Your HVAC is going to be a little more hairy here because you're retrofitting an existing system. $15 million to do it conventional. So that's your cost of renovation. The operating cost is going to be $1.2 million. It's maybe not as efficient as the $1 million on your brand new building, but you're going to get an operating cost that's lower. So it looks like your all-in cost for a conventional HVAC retrofit upgrade, $70 million. What happens if you move to geothermal on this? And this is the contractor geothermal line. So no general construction. HVAC, we've got it at 10 million here. Some part of the HVAC might not be able to be counted as part of the geothermal system. You've got 10 million of geothermal, boreholes, etc. So here you've got 20 million of ITC eligible credit, and you're going to get a 6 million ITC. And so your net cost here, actually in this retrofit case, is slightly below what your conventional HVAC would be. 14 million, very close. And then you'll see in this case, the benefit of geothermal is now you're down at 900,000 a year operating cost. And over time, that means a lot. So there's a big difference in your all-in cost by just going geothermal in general using a contractor. Sounds pretty good. So let's now go to Subterra geothermal. You still have no general construction cost. You have the 10 million HVAC cost and the 10 million geothermal. You've got 20 million of ITC eligible credit built into that project, except here you notice what you pay is 0, 0, 0, 0. And so if you rehab a building, you will now, using Subterra, you're going to get a $6 million back under that contract in a check from Subterra. They're giving you that value. So that's a big difference. As opposed to 15 or 14 million out of your pocket. How about a renovation cost where a check gets sent back to you? That's what you have if you use Subterra for a HVAC retrofit. Now let's go through the operating cost like before. It's going to be at or below what your conventional HVAC is. So you're going to still be paying $1.2 million, same as the far left column. Your 30-year operating cost, 55. So you see in this case, Subterra also is all in lower. But the huge thing that I think people are seeing is you do an HVAC retrofit using Subterra with this kind of a scenario, you're getting an outright check back and you're eliminating your renovation cost. You can use that $6 million for whatever you want. In your 30-year savings, all in is more than 20 million from a conventional HVAC. Okay, now you're wondering, okay, well that all sounds good and I like the model, but have they ever done this before? Who am I banking with? What happens, can Subterra deliver this? So Subterra has delivered over 500 projects successfully for this industry from 2017 when they were formed. They are a long-term player in this, and they have done over 500 projects in Canada, and they are moving strongly into the US now. And we are helping them do that because this is such a valuable proposition, and we have ITCs too. And so the US is a very, very important market for this. A couple cases that have been done Subterra has done already in the US is Oberlin College. You can see this was a 440-acre retrofit. And similar, the budget for the geothermal, 140. After you take out the ITC credit, their net cost is about 100 million, a $40 million savings for them. They're just launching now their project with Fordham University in the Bronx, an entire 85-acre campus conversion in phases, all in cost 100 million, ITC credit about 30 million, net cost 70 million. Even a rich university like that doesn't mind an extra $30 million. And they can go green, and they can comply with Laudato Si, which they are gung-ho on doing. The whole network of Jesuit universities are actually have resolved to do so in a time period. And you've also seen several states starting to mandate this. So there's a carrot and stick approach, penalties plus incentives. So have they done it? Yes. And they are the biggest player in the industry. So really this is all about answering the call, I would say. So the first call is you have to steward the assets you have, as Archbishop so eloquently told us last night, is everything you have is to be stewarded. So you need to start with how are you using the resources you have to begin with for your own university or school or parish. And that's kind of the lens we look at it. It's also you're answering the call to your own constituents, but also for the world and our common home. We need to answer that call. Maybe it's an easier way to sanctification if answering the call requires hair shirts and lots of money. But when actually you can answer the call and generate some more money for your constituents. That's a nice thing. I mean, that's a easier call to answer. And so, we're going to get to is like, why wouldn't you answer this call? It is a way to partner with a proven player to do something that we all want to do, are called to do, both financially and, with our faith. But monetary things come into play. Sometimes you got to figure out where to get the money. So it's nice when these align. And, for that fixed energy fee, and also there's no harm at all. In fact, Subterra wants it more than you, is we have to look into the facts and do a proposal. Since we're owning the system and guaranteeing it, we are the ones got to make sure this works. And so we're able to do that. So what's stopping you from making the call to Subterra today is our thought, at least from your stewardship obligation, to at least look at, might this be a way for you to think about doing your buildings? And so we're here, and we've got Kareem and Matt Tokarik and Zach Schierl from Julius Capital, and we can now do some Q&A. We've tended to leave that for this, so Matt and I will take questions, and I think it'll work, and then we can talk a little bit afterwards if needed.
Yeah, thank you. I think the first question was, is there a height limit? Is that what I heard? So the answer is no, there's no specific height limit. The way that we think about height is really just adding more square footage. And when you add more square footage, whether you're building up or whether you're building out, you require more loops in the ground effectively, more drilling. So there's no specific height capacity, but the more area you build, the more drilling we need to do effectively.
Great, thank you for the presentation. I have two questions. The first one was, how long does it take to actually roll all this out and implement it? And then two was, is there a size, either square footage or dollars, where it does make sense to pursue this, or maybe something's too small for it?
Sure.
Where do you guys draw that line?
So the first question was, how long does it take to roll out? So there's kind of a couple phases. There's the design phase. It's going to be no additional time. We just need to sort of slot into your design team to get all the adequate drawing and planning and those sort of things done. There's some contractual work that we need to do. Again, we can do that within your design phase. So there's no additional time. And then when we're on site, drilling, again, it depends on how much you're actually drilling. For one building that's 100,000 square feet, let's say, you might be thinking about an on-site drilling program that's maybe 3 months plus or minus. And then as you add building capacity, you're pretty linear in that fashion. The one important thing that I'll note, we didn't get too much into the drilling, and maybe we can talk about this offline a little bit further, but if we are going to drill and you need to put it under your building, we will be on site first before you start your shoring and excavation. We will be done all of our work, make sure that we're on and off before you start so that there's no impact to your critical path. So if that's something interesting, we can talk about that maybe offline afterwards. And then the second question was minimum size. So typically for us to do a deal where we're going to finance it, we're typically looking for something in the 100,000 square foot minimum. We will go a little bit lower, but as a rule of thumb, that's kind of our starting point. And then, the bigger the better. There's a lot of economies of scale in these types of systems. So you'll notice that the renewable energy fee will come down a little bit more because of that economy of scale. And typically 100 is kind of our bottom.
Let me contextualize it for a Catholic building, and one that we're going to be starting. We're a nationally recognized bond firm. I do bonds for high schools around the country, Catholic high schools. So we have one in Colorado, can say that is moving forward. So here's the timeline for them, and they don't want disruption. How does it fit in the school system? Things like that. We can work it. So the timeline would be in the winter when the kids are out, come in and we drill the boreholes. Done. In the summer when they're out again, we hook it up to the HVAC. It's a 6-month project. That's kind of one way to contextualize that. It's doable, and if you want to totally eliminate disruption, there's can be timing. Now, that's the advantage of them owning a rig. They can have multiple, whenever you use the window, they can get in there and do the drilling, the borehole making part of it, and then they'll retrofit according to your schedule. So it can be done in 6 months from signing a contract or so if that fits, or it could be staged out over many period of time. I have one question that everyone asks that I want to just have to say in addition to, I'll just put it out there because I know, what geographies can this work for or not work for? Just give you the basic idea is it works best where you have seasons. It works best where it works best in a full loop system where you have seasons. But it can also work in other places with a hybrid approach. For example, in Florida, it would work well in certain areas because they have a high water table. So just we'll tell you, but I'd say, you know, the one type of place that would be really hard to do this is Tucson, Arizona, where they have all heat. I mean, you know, they need cool, and they don't have any water tables or other places to put the heat. But we will tell you if you tell us where it is, whether it's feasible. And you were.
First of all, I want to say that Matt and Michael, you both did a very great job in presenting. I understood everything that you said, and it's great.
Thank you.
Thank you.
One of my questions was answered from the standpoint of what was said over here. What is the smallest space that, well, in your context, that you do? And this other question was, when you deal with geothermal, what is the smallest space that it can be done in? Even though you wouldn't do it under 100. That was a curiosity question.
Yeah, you can do it in a single family home, one single family home.
Okay.
Yeah.
Okay. Now, well, my real question comes in relationship to what you shared was this whole idea of 30 years. I think it's a great program, and I understand that. So 30 years is up. Now I or whoever, we own the project, right? Mm-hmm. So what is the typical lifespan of this? And then now, you sold a good point. If you tell me I get it today, and I'm the one, well, not me or my engineers or whoever, got to maintain it, and you sold me on the fact that we can mess it up and get it off balance. Well, 30 years later, I may ain't be here from my other people. You see what I'm getting at now? So after 30 years, so is it a geo is it's 100-year lifespan. So you're getting the point that I'm going at right here. So how do we deal with it after the 30 years?
So yeah, the lifespan is about 100 years for the stuff that's in the ground, right? This is HDPE, high density polyethylene pipe. This is the stuff that they can't get rid of in landfills, right? It goes in the ground, you never touch it again. The other component of it is the stuff that we put in the building, and it's very simple. What we've done is removed all of that stuff from the rooftop. We've buried that in the ground in the piping, and so really all you're left with is a couple circulating pumps to drive that water. And so that's one of the big reasons why the operating cost is so much lower, is because we removed so much of that. So what you're now considering is, okay, the pipes are going to last for 100 years. So now all you're doing is maintaining those pumps. And within that 30 years, we expect that we will have replaced them at least once. Usually these pumps have a lifespan of about 20 years, for example. So we will have replaced that. You'll have pumps in working condition. And then at that 30 year, if you don't feel confident in operating yourself, you could just hire us to do an operating contract for you and continue with that same program.
Also, to put this there, in 30 years' time, it's a little bit like this there's going to be thousands of geothermal type of maintainers. You could easily contract this, so it's not like you're locked into it. Someone can step in, and you could actually take that over and monitor it on your own, and you just got to keep it in balance. And so there will be a lot of service providers that are able to do that for you. Mr. Eustace.
2 hours from you guys in Rochester, New York. I got 200,000 square feet. The building is a National Historic Landmark. Subgrade existing HVAC. So you'd have to do just a lot of reno to get the existing system out. Explain to me, are you drilling in the building or are you drilling outside the building? And then how do we deal with historic landmarks and all the rules that come with that?
Yeah, in that case, we would prefer to drill outside of the building if we can. So we'd be looking for surface parking lot, green space. So that would be our ideal, and we would just run the laterals through your subgrade wall or wherever it happens to be. That'd be the easiest way to do it.
In a practical manner, if you're in a retrofit in New York City with no parking lot and side by side, that'd be the only time you'd try to drill under the building, and we probably wouldn't do that. It wouldn't work. So usually if you have any green space, any parking lot, so no worries. No worries.
I'm worried about the historic police
And we're not touching the building in that way, so it should work well with historical credits.
Okay. All right, thanks.
Yes.
Are there any entanglements with the tax credit as far as, you know, the Catholic Church having to agree to anti-discrimination federal clauses and woke?
That's, and we're, you know, at my law firm and other parts, we're delving into that. The answer appears to be no at this point. The requirements are things that generally people would want. They do require a prevailing wage, using prevailing wage workers. They also have a really cool apprenticeship requirement, which Maddie and Ross, where they require apprenticeships in this as part of the ITC. So there's a great way to partner with universities and dioceses where you want to actually have some people apprentice on it. But no, we don't know of any anti-Catholic, contrary to our moral teaching, nothing that we've seen there. Yes.
Yeah, Mike, you mentioned Colorado, and you know we can go from 110 in the summer to 10 below in the winter. So how is the efficiency of this system at those really extremes?
Yeah, so what you described there is actually kind of perfect. Remember, the whole concept here is that we've got a thermal battery under the ground, and we're trying to put it through a heating and cooling cycle. So what's really difficult, like Michael said, is in Arizona, where all you have is cooling. You're just rejecting heat all year round. That is a hard case to make work. When you have high temperatures and low temperatures, then you are able to charge and discharge that battery adequately. So that's actually exactly what we're looking for.
Plus, Colorado, pardon the pun, Colorado's a gold mine, for this because it has incredible incentives, almost doubling up on what I showed you there. And they have penalties coming up if you don't do this. So certain states just jump out at you that you got to be doing it. New York, Colorado. Joe.
Hi, I'm Joe Pomeranke. I'm from Golden, Colorado. I just want to first thank you both. And I will answer the call as a steward of Subterra. Michael, you've been an incredible teacher. Matt, it's a pleasure to meet you. I represent Arco Murray. We're the largest design builder in North America, and we can be of service to you for due diligence. I'll be introducing you to our COO after the meeting. I have two statements and one question. My professional statement is very simply what I just said about Arco Murray, and I thank you for the opportunity. My personal statement is I had a dream when I left this great university as a structural engineer, and I got my architectural engineering master's in Illinois, and my graduate thesis was zero energy warehousing, and I studied geothermal quite intensely, and you're absolutely correct about everything you're saying. This is absolutely the right answer. But now for the question, which is why when we studied it 14 years ago, I couldn't get anything done the way you're getting it done. I'm not interested in politics, but it seems like this value proposition could be based heavily on ITCs. It's Michael's expertise, that's why you have a great partner in him. Can you comment how this value proposition changes after election cycles, the IRA timeline, and what is the plan?
We got a lot to talk about. Your history and my history are actually almost identical. Thank you for the wonderful question. The short answer is that this business model works void of any ITCs. We set this up a number of years ago before the ITCs were in place. And the reason it works is twofold. Number one is you get the utility savings on the energy efficiency side. And number two is because we've eliminated those conventional pieces of equipment. These are big moving machines, chillers, boilers. They break down. You need a lot of R&M. And basically buried all of that plant equipment in the ground and replaced it with a couple circulating pumps. The R&M and the capital reserving has gone down precipitously. And so when you look at the total carrying cost of both the utilities, the makeup water, and that R&M and capital reserving, we have a significantly, drastically reduced operating cost, and that is how we make this work.
So can I ask a follow-up question?
Please.
What is the core business of Subterra?
The core business of Subterra, I would say, is packaging this already proven technology. We're not here proposing a new technology. Geothermal has been around for 100 years. We are proposing a solution that packages the technology in a creative financing solution that removes the primary barrier, which is capital cost.
I would say, I want to jump in. The technology works. You know, that middle column I showed you, you could pencil that out. The fact is, Subterra comes with the backing of $1 billion infrastructure fund. And so there's no separate proposal bidding. As if we hit the mark, which I just laid out, the 9% IRR energy fee, the money's there. So Subterra is a financing vehicle. That's how they can pay for the whole thing. And they're very good at selling this. So the fact that they sold in an infrastructure fund to say, here's your kind of capital available, means it's already been tested. So ultimately, brilliant engineers, leading number of rigs. This is important to have. So they are vertically integrated on the operational side, but the financing component added to that to be able to offer this will pay the entire CapEx. Those two things together give their value proposition, and it's undifferentiated from anyone.
Yeah,
There's nobody that can do that.
Yeah, and that's a perfect point. And we didn't touch the whole conversation today was about the utility business. We have a whole other business that we didn't talk about at all here, which is the drilling and installation business, which is its own massive operation. And that is a massive differentiator for us. There are a couple other people who are the ESCO types who play this middleman financing game, but they're outsourcing everything. We've got the whole package inside, which is what makes us.
When someone else proposes a contracted geothermal, they're probably calling Subterra to beg for the rigs to come when they pitched it to you. Subterra says, I don't know, we could if we have extra capacity, but we're going to do our clients first. And that's why they can do the borehole so fast. They might put 4 rigs on there and do it in 2 weeks and be out and in. No one else can touch that on the operational side. And you have a question.
I have a couple really quick, and I'm sure you'll hit them pretty well because you've done an excellent job so far. On an existing value add project, what of the current system remains for either cross utilization or use, and what comes out, and then what sort of aesthetic factor from your process is also remaining post project?
I'm going to say one thing, then I'm going to add.
No
So I used just 2 cases, brand new building, retrofit building. But Matt can tell you more. Yeah, it's just if you're doing one-off for that, and it works. But if you have a campus or a system, a whole bunch of other kind of benefits can accrue, like places to dump off the heat, you know, taking something from your pool and feeding other buildings. So Matt, talk about the synergies if you're actually doing not a one-off.
Yeah, and let me just make sure if I oversimplify the question, I think what I'm hearing is, in a retrofit scenario, how much of your existing HVAC can you reuse? Or is needed. Okay, so the answer is it depends, which are answers that I hate to give. But if you've got a building that is already set up with a relatively new HVAC system, let's call it, that's got a hydronic piping system out to fan coils, VRFs, heat pumps, you can reuse almost all of that infrastructure, and all you're changing is the plant equipment. Change out your chiller and boiler and replace that with a 6-pipe heat pump machine, effectively, okay? If you've got an old church property, for example, that all you have is high temp rads, heating, and no cooling, or maybe just window shakers, picture something like that, then you're gonna have to rerun distribution piping so that you can get that hydronic system throughout your building. Does that answer the question?
Yeah. And my last follow-up question is, have you looked at partnerships with solar or wind for the supplemental electricity costs to be able to bundle a full package?
Yeah, we have looked at those, and that is something that we could potentially include in the financing package as well.
A lot of you have solar already. Remember when I showed that? You still have an electric bill. So what you can do then, if you want to have no bills, you just use your solar to run the electricity. So it plugs into that perfectly. And you're going to have excess energy from your solar, and you can sell that back. You can make money on that. So we assume that you're still getting a utility bill for that electricity, but you could add solar to this, and now you're entirely kind of on your own with fully green. Trey.
So first question, how long does it take to dig a hole 1,000 feet into the ground?
Yeah, it's a good question. One drill can do it in a day for thumb in the air type of measures.
Okay. And then, so second question, has it been difficult at all or an obstacle for you to walk the universities or whoever you're working with, to walk them through this? And is there ever a fear that you encounter about geological issues or this causing some kind of, concerns about structural issues of having that many holes in the ground below their building? Or, causing an earthquake, just kind of different fears like that and kind of allaying those concerns?
Yeah, let me see if I can distill the question there. So structurally, no. We in probably the majority of our cases in Toronto, for example, where we're based, are building on infill projects that are lot line to lot line. So we're putting all of the drilling underneath the building. And when we lay them out, we will typically resolve them outside of the structural footing, right? And so they it's a hole, and it's not an empty hole. It's full of grout, which is like clay, sort of. So it's not like there's any vacuums or places to settle. So structurally, there's no issue even being under the building. From one of the questions we often get, particularly folks from the Northwest, Pacific Northwest, is about earthquakes. I know for a fact that places like Vancouver and Seattle, which are very green and forward thinking, have probably more geo than many places in the country. But the way to think about it is that an earthquake and seismic events have the most translation, most movement at the surface, and actually very little down at the bottom. So the pipes, and the pipes are plastic, so they have a little bit of bend to them. So the pipes are fine. In an earthquake, if you've gotten to a point where the pipes have broken, your building is down and you've got bigger problems to worry about than the geosystem, frankly. And then the last one I'll address maybe is groundwater. So as we're digging, we're going through the water table in all cases, effectively, because we're going, again, 1,000 feet, you're going to hit and exceed your water table. And so as we go down, this is where some of the regulations come in that we have to comply to. We are generally casing the well as we drill, which is a steel pipe, effectively, that we put down until we get into solid rock. So that steel casing stops any of the water from penetrating through. And then once we get into that solid rock, again, we've got either a working fluid like a mud that's down the hole, resisting any of the water coming in. And then once we're done drilling, again, we fill that hole back up with grout. So at all times, we've got a pressure that's pushing the water from coming back in.
Okay. Thank you.
John.
I represent the Ladakhtsi Action Platform, and we have over 240 dioceses signed up worldwide. So my question is, you're talking about big scale university issues, and I'm thinking about dioceses with hundreds of churches, and I'm wondering if you've thought of scaling this to respond to diocese groupings of projects, and whether that might be a beneficial kind of approach.
I can talk to that one too.
You want to talk to that, Jose? I'm
Yeah.
happy to, but you go. Go ahead.
Okay. Just in terms of, I know the dioceses. I mean very well. It's where so we are absolutely talking to the dioceses, who essentially they have inside their diocese several projects. So we're trying to do a coordinated look at all of their things. So this will tie into. We would like to go with dioceses that want to do this, and they can be basically the front end coordinator for the scaling of the projects, and we are doing that. And several dioceses have started already, so that's exactly what we're going to do. We're going to plug into the church network, and it will be more efficient all around. Plus, it helps for them to vet this project type of thing up front, and to give us their priorities of where to go. So, yes, we want to collaborate with the diocesan network interested in this. We are right. We will hang around here for some more and then do lunch and that. All right.